10.3 study guide and intervention is on geometric sequences and series. So first of all, we have this formula here that's highlighted. We'll use that to use geometric sequences. Number 1 says determine the common ratio and find the next 3 terms of the geometric sequence. Well, hopefully you can tell in this sequence right here that your common ratio is simply 2. You're just doubling. And so the next 3 terms would be, oops, not 6, but 8x, 16x, and 32x. Problem number 2 says find the 7th term of the geometric sequence. So again, to figure out the common ratio, which is an important piece here, what we do is we take the second term, negative 47 point, oops, let's write that correctly, negative 47.1, and let's divide by the first term, 157. So if I go to the calculator now, type in negative 47.1 divided by 157. That gives us a negative 0.3 for our common ratio. So now, to find the 7th term, I'm going to use the formula. And again, the formula is A1 times r to the n minus 1. So what I'm going to do is to find the 7th term, I'm going to take the first term, 157, and multiply it by negative 0.3 to the 6th. So 157 times negative 0.3 raised to the 6th gives us a value of 0.114453. Number 3 says find the 17th term of the geometric sequence. Well, again, we need to find that common ratio. Hopefully by looking at this you can tell that the common ratio is 1/2. And so let's use the formula to find the 17th term. We need the first term, 128, times the common ratio, 1/2, raised to the n minus 1. In this case, that's going to be raised to the 16th. So 128 times 0.5, or 1/2, raised to the 16th, gives us an answer that's pretty dang small. Let's try changing that into a fraction, see if it works. Yeah, 1 over 512. A little bit easier to write. So there's your 17th term of the geometric sequence. Number 4 says, find the first term of the geometric sequence where the 6th term is 0.1 and the common ratio is 0.2. So again, using this formula here, we know that the 6th term, if I put 6 in for n, this should equal the first term times the common ratio 0.2 raised to the 5th power, because we're putting 6 in for n. But then what I can do is I can erase this a sub 6 and I can put its value in, which is 0.1. And so now to solve this, a1 would just be equal to 0.1 divided by 0.2 to the 5th. 0.2 raised to the 5th, and that gives us 312.5. Number 5 says find the common ratio r of the geometric sequence where the first term is 15 and the 10th term is 7,680. So again, using this formula, let's see here, since we're putting 10 in for n, and we know that 15 is the first term, we don't know r, but we are putting 10 in for n, so I'm going to make that exponent a 9. Now I can go back and erase this a sub 10, and I can put its value in there, which is 7,680. So to solve that, we'll take the 7680 and divide by 15. That gives me 512. And so if I've got 512 equals r to the 9th, all I have to do is take that 5/12 and raise it to the 1/9, like that. It gives me 2. So my common ratio, you can see it's multiplying by 2. Now moving on to geometric series, you can see we've got this formula here, and we also have this formula. And then I accidentally didn't get this one highlighted. I wanted to, so if you had a highlighter, you could highlight that. I think there's one below that's highlighted that's identical to the second blue one that I circled. But these top two formulas circled in blue, they are for finite geometric series. But the green one is for infinite. And remember, if you use that green formula, you only can use it if the absolute value of r is less than 1. So keep that in mind. It says that right here. So, number 1 says find the sum of the first 7 terms. That's finite if it's the first 7 terms. And so, S sub 7 would equal, now I'd like to use this second formula because all we need to know is the first term, the common ratio, and n. So, since your first term is -1, the common ratio you can see is 4 raised to the 7th, 1 minus 4 on the bottom. And now if I go to my calculator and type that in, I'll get my result. So we got 1 minus 4 raised to the 7th over 1 minus 4. And that would give us an answer of negative 5,461. Number 2 says find the sum of a geometric series where the first term is 8, the last term or the nth term is 0.394, and the common ratio is 9/11. So S sub n, even though we don't know how many terms this is, would be equal to 8 times 1 minus 9/11 raised to the nth over 1 minus 9/11. So now we have to figure out what n is. So there's 2 ways we can do that. So since the common ratio is 9/11, we could do this. So that would be the second term. That'd be the third term. Fourth term, and I can keep going like that until I get to the value right here, 0.394. The other way of doing this would be to use the formula and set 0.394 equal to 8 times 9/11 raised to the nth. And now I got to figure out what n is. So if I take the 0.394 and if I divide by 8, and now what I can do is I can take the log of that number over the log of 9/11. So the log of this divided by the log of 9/11 should give us our answer. So n is 15. And so I'm going to put 15 in for n right here. And that should give us our value. So it looks like the sum of the first 15 terms would add up to give us raised to the 15th, 1 minus 9/11. Takes a while to type that baby in. Gives us 41.831, roughly. Okay, number 3 says find the sum, and this is sigma notation, so you get the first term by plugging in 5, the second term by plugging in 2, so on and so forth. So since we're finding the sum of 11 terms, we need to know the first term, and that's just going to be 5. Our common ratio is 1.06 raised to the 11th. So that's what we'll type in to find the sum of the first 11 terms. Again, that's 1 minus 1.06 raised to the 11th. 1 minus 1.06. And we get a sum of about 74.85. Number 4 says find the sum of the first 16 terms of a geometric series where the first term is 1. And now this is a recursive formula. So what that's saying is that if the first term is 1, the next term is found by taking 1 times negative 2. Then the next term is found by taking negative 2 times negative 2. So there's your series. And so if you're going to find the sum of the first 16 terms, we take the first term 1 times 1 minus negative 2 raised to the 16th divided by 1 minus negative 2. So if so we don't need parentheses, we can just go 1 minus a negative 2 raised to the 16th over 1 minus a negative 2. Negative 21,485. Oops, that's 800. I wrote that wrong. 845. So that represents the sum of the first 16 terms. And then your last couple of problems, you can see number 5. It's an infinite geometric series. So we have to use the infinite formula, which is going to be first term found by putting 1 in for n. That gives us 13 divided by 1 minus the ratio, which in this case is 3/8. And if I go to my calculator now, we get 13 over 1 minus 3/8, and that gives us a total of 104.5. If you want that as a decimal, it's roughly 20.8. And then number 6 is also an infinite geometric series, but you can see that the common ratio is 3, so this does not exist because the absolute value of r is greater than 1, and it needs to be less than 1. So the sum does not exist.